Hello everyone, this is Dr. Gupta, and today we are going to discuss one of the critical topics from the domain of industrial engineering. It is known as method study. Now, what happens whenever the operation that is being executed, the work that is being executed in any industry is labor intensive? It requires a lot of labor. In that case, it becomes important to carry out method study. Different workmen may approach the same problem by different methods. So, some of the worker might be able to produce more in a given time compared to other worker. So, what is required basically is to standardize the method. Once the method will be standardized, it is tried to achieve similar efficiency among different set of workers to fix the productivity of operations so as to channelize the orders and production. So, in labor intensive industries, we carry time study as well as method study a lot in labor intensive operations so as to optimize the methods as well as the time consumed to produce any particular piece or of work. Okay. Now, we'll first introduce method study. Now, what exactly is method study? It is a systematic way of observing the work, recording the facts related to the work, the fact related to the method followed during the work, and these methods are then critically examined so as to optimize or to create the best possible method of executing the work at minimum cost. So, this basically is the way to define method study. We'll see that in detail. Now, what prompts us to carry out method study? What forces us to carry out method study? Number one, when we see the operations are labor intensive, a huge amount of labor is involved. Second, when we have a good understanding of the human factors that are involved. For example, if I don't keep the allowances while defining the time of doing a work, or if I don't consider the human constraints while defining the method, in that case, I may come out with a wrong method. So, two of the aspects are required. Number one, that should be labor intensive. Second thing is we should have good understanding of human related factors. Then only we can carry out method study efficiently. Now, the scope of method study lies in improving the methods related to manufacturing operations. Maybe we might also require to change the sequence of operations for getting out a better method related to workmen, the body posture, the ergonomics, and related aspects. Related to materials, tools, and gauges, we may come out with better gauges, better tools, jigs, and fixtures so as to make the work easy. Related to layout of physical facilities and workstation design. For example, if a worker requires to bend continuously to perform a task, he might find it difficult. So we might raise the table to certain height so as to allow it to the worker to conveniently handle the object without bending his body. So layout of workstation as well as physical facility might also be modified. That is also required. Then movement of man and material handling also might require to be optimized in the method, as well as the environmental condition might also be required to be smoothened out. So all these aspects are taken into consideration while coming out at right method. Now, objectives of method study, as we have already discussed, that whatever is the purpose is number one, to improve the efficiency. It is the most important purpose. Second, to design the entire flow of work, also considering the human constraints as well as production constraints. So, number one aspect is to improve the efficiency by improving the layout, proper design of workplace, by improving the work procedures, by effective utilization of man, machine, and material, as well as by improving the design and specification of the final product. Now, how this objective might be achieved? Only when we observe the facts the way they are, then we examine the facts so as to come out with best possible method. We have already discussed the scope lies in improving the work, improving the material flow, improving the human utilization, eliminating the waste, and reducing the manufacturing cost. Now, what are the steps that are involved in carrying out method study? Now, as we know that method study is broadly a part of work study. The other aspect of work study is time measurement, time study, work measurement. Now, method study is carried out with certain steps. Number one, we select the job. The job which is labor intensive, as we have discussed, is normally selected for method study. Then we observe the way in which the job is being executed. That means we record the facts related to job. We examine the facts that we have recorded. Then we try to develop a proper method of carrying out the work. We define the method, the standard operating procedures, and related aspects. We install that method for doing that particular work, and then we end up maintaining the method so that there are no such deviations recorded. So these are the general steps. So whenever, even if in you see work measurement, the steps are similar. Number one, you select, then you record, you examine, you develop, define, install, and then you maintain the things. So these are the general steps to carry out method study. Now, the very first step that we were discussing is selection of a job. So how a job is selected to carry out method study? As we have discussed, one of the important aspect is it should be labor intensive job. The job should be highly requiring the labor work, the human work. So it should be labor intensive job. Other than that, we have economic aspect as well as technical aspect. If the job is requiring huge investment, then it is utilized for method study so as to improve the method. There might be some technical constraints that forces us for method study. So economic aspect, technical aspect, and human aspect, all these three are the important parameters for selecting a particular job to carry out method study. Now, normally 5 symbols we utilize to draw the method study chart. Now, these are those 5 symbols. The first one, a kind of elliptical symbol, it represents operations. So, whatever operations are being carried out in a particular work, they are shown by this elliptical symbol. Another symbol is for inspection, a rectangular symbol. Another arrow kind of symbol for transportation. The another symbol, semicircle kind of symbol for delay. and the inverted triangle kind of symbol for storage. So normally whatever job is being done, we classify everything corresponding to the job in these five categories. Either it can be classified as operations, or it can be classified as inspection, or as transportation, or as some kind of waiting time, some kind of delay, or as storage. And correspondingly, we are going to use the five symbols to represent those particular aspect of doing a job. Now, what is operations? So whenever some actual work is being done to modify the job, that is being known as operation. For example, if you are carrying out some kind of turning operation, some kind of machining operation, something on the job, this is actually varying its characteristics, maybe the physical characteristics, the chemical characteristics, the mechanical properties. So whatever operations that you are doing, all these things are classified in this category. Then what is inspection? So whenever we are examining the job to test it against the standard quality parameter, then that kind of things are categorized as inspection. It means we are carrying out either visual inspection, or maybe using some gauges. We are checking the quality for the specification of the job. So all these things are categorized as inspection. Transportation. Normally, transportations take care of movement, maybe the movement of worker, or the material, or the equipment. Any kind of waiting on the part of job or on the part of machine is considered as delay. And finally, the last symbol that represents storage. Now, what is storage? Whenever something is kept in some custody, or maybe at some point where it is stored, maybe temporarily or permanent, so that kind of aspect is taken care of by this fifth category, that is storage. Now, in order to carry out method study, we have different kind of charts. The very first chart that we draw for method study is known as operation process chart. Now, what is operation process chart? We know that all the things that are being done to complete a work are categorized into five categories: operation, inspection, transportation, delay, storage. So, out of all these five, if we only record the operation and inspection, we don't take care of transportation, delay, or storage. We simply record the operations that are going on and the inspection that are going on, and we draw the corresponding chart. The chart is known as operations process chart. So we are not focused on the detailed perspective of the shop floor. We are only focused on bird's eye view. Whatever is going on the shop floor, we are looking from the bird's eye view, and we are only recording operations and inspection in the first category. Now, there is a second kind of chart. Let me show you operations process chart once. So this kind of chart is operations process chart. You can see the elliptical kind of symbol, this kind of symbol, circular elliptical kind of symbol, it is representing the operation, and this another rectangle square kind of symbol, it is representing the inspection. So only operations and inspections are mentioned. No transportation, delay, or storage are mentioned, only operation and inspection. So it gives the bird eye view of whatever is going on to a shop floor. So that is known as operations process chart. So herein they have mentioned 20 operations, maybe 5 inspections. The time that is required for 20 operations, they have added all the time, they have calculated it to be 17.58 minutes. And for inspection, they have mentioned it is the entire day work. So in this way, we draw the operations process chart. Here they have drawn the operations process chart for some certain activity being carried out. So this is the first kind of charting method for method study analysis. The second approach is flow process chart. Now, flow process chart is broadly of three categories, maybe a man type, a material type, or an equipment type. Now, whenever the things that are executed by human being are plotted, then it is known as man type flow process chart. It includes all the five symbols. So let me clarify. All the three flow process chart shall include all the five kind of symbols: operation, inspection, transportation, delay, and storage. Now, whenever we are making the chart from the perspective of human being that is involved, it is known as man type flow process chart. Whenever we are making it from the perspective of the material that is involved, it is known as material type flow process chart. And whenever we are making it from the perspective of the equipment that is involved, it is known as equipment type flow process chart. So three category of flow process chart can be made. Let me show you the example. Now we'll see all the three types. So in one of the flow process chart, we are making it in material kind of way. Material type, component. Material is being highlighted. Component is being brought from store. Component is being loaded on the machine. Component is being machined, and so forth. So you can see the material type flow process chart for this problem, the illustration problem that is given. So in this, we are using all the five symbols: operation, inspection, transportation, delay, storage. All the five kind of symbols are being used, and the corresponding material type flow process chart is being drawn. The operations, their frequency, the corresponding time, maybe the distance is being noted down. So this is a way to draw flow process chart in method study. Let me show you another example. Man type flow process chart. So there is an example wherein some worker goes to the cabin of his officer and then takes the dictation from the officer and then types the letter and bring it back to the officer for signatures. So this is man type job, and then it is further classified into the five set of categories, and the man type flow process chart is being drawn. So this is a way of drawing the flow process chart in man type case. Likewise, you can also draw the flow process chart for equipment type category. Now here in the flow process chart is drawn in a different style. Here it is directly drawn in the sequence of operation kind of style, and here these points and lines, connecting lines, are showing the sequence in which things are being carried out. So herein it is drawn in some other style. So this is the third type of flow process chart. All the five symbols are utilized, and herein some kind of equipment kind of flow process chart is made. So whenever we go for detailed view of whatever is happening, maybe regarding to some certain job on the shop floor, we make a detailed chart, and that detailed chart is known as flow process chart. There can be the third kind of chart, multiple activity chart. Now we may plot different things together on a common time scale. Maybe we might feel like plotting man and machine together on a common time scale, or man and material together, or machine and material together. So in that case, it is known as multiple activity chart. The fourth kind of chart is two-handed process chart. Now what happens if there is a case when the worker normally requires to use both the hand together to execute the job? In that case, we draw two-handed process chart to show the activities being performed by both the hands of the workers. So that is the case of two-handed process chart. We might also draw the travel chart to represent the movement in between the departments, or we might also draw the simultaneous motion chart, CMO chart, to show the different motion being executed simultaneously from different part of worker's body. So all these different kind of charts are being drawn to carry out method study in different conditions. Maybe the worker might be working on assembly of watch, so it is just like a workbench wherein the entire operations are being done. So you might require to draw a symbol chart in that case. So there are different charts for different category of operations. Now we have seen the operations process chart. We have also seen the flow process chart. Two-handed process chart, as we have discussed, we can see that both the hands, the activity done by both the hands are plotted together and are being analyzed. So that is known as two-handed process chart. Multiple activity chart. We have seen that in multiple activity chart, two of the aspects, maybe the man and machine or man and material or machine and material, are plotted together so as to identify the waiting time or the idle time or the efficiency lapse in the execution of a job. For example, here you can see that at a point the man is idle, or maybe at a point the machine is idle. When the man is working, the machine is idle for a larger duration of the cycle. So some possibilities can be worked out to load the machine so as to remove this idleness. So this multiple activity chart help us to compare the different elements of production, their relationship with each other, their execution way, and we can efficiently utilize the factors of production by drawing this kind of chart. As we have discussed, the travel charts or the travel diagram are drawn uh, basically in two categories, namely flow diagram as well as string diagram. Now, what happens in flow diagram and string diagram? Whatever traveling is happening on the shop floor, that travel is being plotted. So, what we are doing, we are taking a board, we are putting different pegs representing the different machine and equipment on the shop floor. We are doing it on a particular scale so that we can measure the actual distance by multiplying the scaling factor. Then in between the pegs or maybe the representations, we will either draw lines or we will tie strings. So there are different kind of charts. Flow diagram, when we draw the lines to represent the movement, or string diagram, when we tie the string to represent the movement from one machine to other machine on a board or on a piece of paper. Now, the advantage of using string diagram is we can tie multiple strings to represent a multiple movement, maybe between a pair of points, or maybe we can tie different color of strings to represent a sequence of operation, the movement, or maybe the multiple movement between two pair of points. So that can be done in a string diagram, and therefore it is advantageous. Now, what is the benefit of making this kind of diagrams? We can actually measure the travel on the shop floor by measuring the length of the screen or by measuring the length of the line in case of flow diagram, and by multiplying the scaling factor we can actually measure what exactly is going on in the shop floor in terms of movement. Now we cannot keep actually moving the machines many times, but we can move the corresponding equipment on this board from a place to other, and we can see by what possible combination the movement can be minimized so as to improve the efficiency. So whatever is happening on the shop floor, we can simulate it on a board or maybe on a piece of paper, and then we can create multiple possibility and check the best possible combination, and then can implement it on the shop floor. That is the advantage of this kind of diagram, string diagram or flow diagram. Now, as I have discussed, citing one of the examples, see why we are making this kind of charts, maybe the table and charts, because we want to identify whatever is going on in the shop floor, and then we want to optimize that. That is the purpose behind doing these things. Now, if in a case when only a single person is involved, maybe in doing the entire work. For example, suppose let us consider assembly of mechanical watches, manual assembly of mechanical watches. Now, traditionally, it is being done on a table. A single worker sits on a table and carry out the assembly operations. But these assembly operations largely involve his hand and eye movement. So the idea is to carry out the micro motion study to categorize whatever movement of eye is happening over there, whatever movement of hand is happening over there, to create a video, to shoot a video, and then to carry out the micro motion study to see whether the hand and eye movement are optimized or not. And whatever unnecessary movement are there, they has to be eliminated. So this idea was very first proposed by Frank Gilbert. He created a set of thermalics to represent the different movement of body, maybe hand movement, eye movement likewise. And then for a operator working on a single workstation, he carried out this kind of micro motion study by filming the entire set of operation, by comparing it with thermalics, and then eliminating unnecessary movements. So we'll see what exactly are thermalics. Now, a group of around 17 thermalics were given. So you can see for search, there is a eye movement, it is mentioned. For find, there is another movement, select. So a group of thermalics were given to record whatever is going on the shop floor. Okay, for inspect, reposition, releasing a load, rest duration, whatever. So he has created a set of thermalics. Now what he used to do, he used to film, he used to make a video of the entire operation that is being carried out by the operator when the single operator may be involved, maybe one or two operators are involved on a single or maybe one or two workstations, and the entire job is being executed. So the entire operations were filmed. Then using this thermalics, the data was analyzed and unnecessary movements were identified, were eliminated using thermalic, and the chart thus created was known as simultaneous motion chart, SIMO chart, because in normally in such cases, hand and eye movement or maybe multiple parts of body move simultaneously, and some unnecessary movements are can be possibly eliminated. So it is simultaneous motion of different parts of body, and therefore the chart is known as SIMO chart, simultaneous motion chart. So it is a recording technique for such kind of micro motion study based on thermalics, and then we try to optimize the operations. So there is a format. So the counter reading, the movement of hands, likewise, corresponding thermalics. Now, if suppose you don't want to carry out a very detailed micro motion study, that might not be required in few of the cases where the cycle time is sufficiently large. So in that case, instead of shooting the entire video and analyzing the entire video, the another approach was formulated wherein the pictures were taken at some regular interval of time, maybe half second or 4 second to 4 second. So they fixed the time in between this uh, duration, and the pictures were taken at such regular interval of time because we didn't wanted to carry out micro motion study because of large cycle time, maybe 5 minutes, 7 minutes cycle time. So memo motion study was preferred. So instead of analyzing the entire video, pictures were taken intermittently, and these pictures were then analyzed to identify whatever is going on in the shop floor and to optimize and eliminate unnecessary movement and to improve the method of execution. So that kind of study is memo motion study. Again, for movement, some other kind of methods were designed to record the movement, maybe known as cycle graph or chronocycle graph. So some kind of electrical bulb was connected to the worker's hand, And as the worker used to move his hand, this electrical bulb was made to create impression on a photographic film, and therefore the movement of hand was recorded, and this was used to analyze the movement of worker hand. So such kind of techniques were evolved, which were known as cycle graph and chronocycle graph. In chronocycle graph, not only the speed but also the direction of movement, everything could be recorded quite easily. So these were again the techniques to record the movement of worker's arm. Now, once we carry out method study using all the possible methods, or maybe one or two of the possible methods, whatever is possible to be implemented, next important aspect is to critically examine the facts, understanding the human constraints, understanding the work requirement, understanding the environmental conditions. Every such aspect should be taken care of while critically examining whatever data we have collected, so as to identify the facts and to come out with best possible method. So you can see here the set of questionnaire is given to examine the data that is being recorded, to carry out the analysis, and to identify the unnecessary or wastages in a particular method. Now, once you have identified whatever is happening on the shop floor, then you have examined it, you have identified what are the unnecessary, inefficient movements, then you can simply eliminate those unnecessary, inefficient movements. You may combine the operations if required, you may alter the sequence of operations if required, and then you can come out with best possible method of executing a particular task. While designing such kind of methods, we utilize the three set of principles which are important. Number one, the optimum use of human body. It should be ergonomically designed. The method should be ergonomically designed. We may also try to make worker use both the hands together while doing a job so as to maximize the efficiency. We might also, for example, you have seen while driving a car, you use the entire body together. You use your eye, you use both the hands, one hand for shifting the gear, the other hand for steering control for most of the time, and you use your legs also. So the workstation is designed in a way that maximum utilization of human body can be done without creating much fatigue. Also, there are another set of principles that apply to arrangement of workplace. The workplace has to be arranged in a proper way so as to improve upon the efficiency, not to compromise it. There might be requirement of jigs and fixtures, so that has to be created. The tooling and equipment has to be placed in a proper place. So all these things are categorized as these principles which apply to workplace arrangement. There are also principles which apply to design of tooling and equipment. For example, we make use of gravity as and where it is possible to ensure easy movement from a higher altitude to a lower altitude. So design of tooling and equipment are also governed by a set of principles. So herein I have listed the principle regarding the use of human body, regarding the workplace arrangement, and regarding the design of tooling and equipment. So I will share the presentation with you. You can go through this set of principles. Okay. So maximum utilization of human body is being targeted without creating much fatigue. Likewise, the workplace has to be properly arranged so as to improve the efficiency, as well as the tooling and equipment has to be properly designed so as to make use of available energy without excess power requirement. Now, once the right method using all these concepts is being designed, then this method is recommended to management for approval, followed by implementation. It is implemented, followed by maintaining the method by regular monitoring, control, and auditing the corresponding benefits in terms of efficiency and cost control. So these entire things represent the method study and related aspect. So thank you all for patient listening. So this was all about today's lecture.